let's take a look at some of the graphs that relate to energy and kind of what we can figure out from those graphs. So, graphical reasoning. As a reminder, anytime you look at a graph, you should think about the slope of that graph, and you should think about the area of that graph. So does delta y over delta x look like something that you know? So delta y over delta x. And does delta y times delta x look like anything you know? So as an example, if I look at a force versus time graph, a force versus distance graph, then the area, F over delta x, that doesn't seem like anything familiar, so we don't care about it. But F times delta x does look like work or a change in energy. So the area on a force versus displacement graph will be the work done or the change in energy. Next we have a, work versus time graph. Well, in this case, if we look, we have work over change in time. That does look familiar. That looks like power. If we have a work times change in time, that doesn't look like anything familiar. So let's look at the two main things that we did, and let's expand those relationships. So force times delta x is equal to work. This means that you have the area, so work is the area of force versus delta x. If we want to rearrange this, we can get force is equal to work over delta x, so this will be the slope of work versus delta x. That's a weird graph. You're not typically going to see that, but I do want to point it out in case it did come up. Same thing with delta x is equal to work versus force. That's also a weird one. You're not typically going to see that. But technically, if someone made you that graph, you would know that the slope of a work versus force graph would be the change in position. These are weird. We won't typically see them. This is common. Likewise, let's look at our power relationship. We already talked about one. Work over delta t is equal to power. So this is the slope of, that's going to be work versus change in time. That is common. You will see that. We can rearrange it. Work is equal to power times change in time. This will be the area of power versus change in time. This isn't quite as common, but you will see this one from time to time. And then there's one last permutation. Delta t is equal to work over power. So this would be the slope of a work versus power. And that also is a weird one. So there's three that you would most likely see. Again, those first two, the ones I drew originally, those are by far your most common. But this is, again, thinking broadly about any time in physics. We see a graph, just run through, does delta y over delta x mean anything or look like anything? Does delta y times delta x mean anything or look like anything? Let me know if you have any questions, but otherwise I will wrap up here.